Hello everyone and welcome to yet another Mitsubishi Electric live podcast. So today we will be talking about the lithium-ion battery industry. And today I have Klaus Petersen with me. So Klaus, I think we had many conversations before.
We did.
But this is probably the first one that is being live recorded. How do you feel about that?
Well, I feel a bit excited, and I'm excited to talk about, specifically the cell manufacturing process today and how data actually can unlock potentials, a new potential inside that area.
Yeah, so you are now responsible for the industry on our side, on Mitsubishi Electric, and I think you have a lot of experience to share with us today. So I'm happy that you joined. So let me start the conversation, and my first question would be probably a bit controversial, I guess. So would you say that the e-mobility is more sustainable than standard car manufacturing? What is your take on that?
Well, I mean, to be fair, it's Friday, and I could say no, and we could close the podcast here and simply all start the weekend earlier. But no jokes aside, seriously, I think you put this question in the present, but I think it would be far more valuable to put it into the future. And by asking the question, does electromobility actually have the potential to become more sustainable? And there, the question to me is yes. Specifically, when you look at the way that, or when you look at the life cycle of the two technologies, conventional cars and EVs. We look at the production, we look at the operational mode, so once it's been handed over to the driver, and then we have the end-of-life recycling. Well, during production, both technologies will emit a certain amount of CO2. But when you look at the moment you start driving the car, today, of course, we know that generating electrical power comes with a certain CO2 emission. But the more we will get renewable energies, the lower this footprint will get for the electrical car. And the conventional car does emit CO2 with every liter of fuel consumed. So, in my opinion, it definitely has the potential to become sustainable from that perspective, from the CO2 perspective. But sustainability is a far more complex topic. And I think if we started to tackle this topic, we would not just need this podcast, but a few more.
Well, that's something that we can arrange for sure. But okay, let's stay in the present then. So when we are talking about the current situation, what makes the production process so energy intensive as of now?
Well, the process I'm focused on is the cell manufacturing. Mm-hmm. And cell manufacturing is obviously one of the bad boys in EV today. But on the other side, it's the savior, because without batteries, there's no EV. So we have to store the electricity somehow to get somewhere with that car. But as I said, it's a bad boy. And why is it so? Well, it's quite energy intensive. Why is it energy intensive? We have a drying process. So when we coat the film, we coat it with a substrate that is still a little liquid, and we need to evaporate all these solvents inside. And that means that we have to get that film through an oven. And that oven consumes a lot of energy. That's the one thing. And the other thing is that the cells are manufactured in dry room environments. And these dry room environments are actually also contributing quite a lot to that CO2 bill, or to that energy bill. So what does it mean for the energy bill, or let's say for the CO2 emissions? Well, there's an interesting research conducted through an academic work at the University of Gothenburg in Sweden. And they looked at two different factories. And they came to the conclusion that to produce 1 kilowatt hour of battery capacity, you require 50 to 65 kilowatt hours of electrical energy. Mm-hmm. So that's actually quite a huge ratio. But we need to compare this with the production capacity that we are actually aiming at in Europe. And when you look at the website of the batterynews.de, they have a nice battery atlas, and they really did a great job there. So when you look at that, and you sum up all the gigawatt projects in Europe, you end up at 1.6 terawatt hours. 1.6 terawatt hours, if we take back the ratio, and which we take into consideration the ratio that was found out by the University of Gothenburg, we end up at something like 80 terawatt hours of electrical energy. That's actually quite a lot.
And probably it's the current situation, and in future when we expect to have many more batteries produced, right? It will be even a bigger problem.
Absolutely, absolutely. When you look at another statistic from Statista, so I think that's a German portal, they have actually published the CO2 emissions per kilowatt hour in Europe, depending on the countries. And when you break down these different gigawatt factories into the different regions, and you take the average CO2 emissions per kilowatt hour in the respective countries, and you make this math, you end up with 2 million tons of CO2 emitted yearly with that production capacity. So actually there's a lot that needs to be done here. But let's say once we have the renewable energies, we still have to look for the quality of the product. Why? The quality in cell manufacturing is actually quite a hot topic. Why is it so? Because it's a quite difficult process to run, to operate. And that's because you nearly run blind until you get off end-of-line testing, where you actually see what the quality of your cell is. And what is the quality of the cell? That's the capacity, the inner resistance of the battery, and a lot of other parameters that you measure. So it's quite a difficult and very challenging process to control. And with the more waste you produce, obviously, the more resources you are actually wasting.
Mm-hmm. So when I'm listening to you, I can hear that in this industry the battery problems might be related to the energy consumption. Definitely you want to create batteries with the right quality. And energy, quality, those factors we have discussed also in the previous podcasts. And usually the answer was data. So using the data to improve the process, to improve the quality, to reduce the energy use, that is what has been discussed. So is the lithium-ion battery industry in any way unique in this regard, or can we apply, data science to improve the production? What is your opinion on that?
Well, are the challenges in the lithium-ion battery business or battery cell manufacturing process unique? I don't know. I don't know all the industrial and possible applications around the world. But they do come with certain challenges, absolutely. And before we talk about how to use data, I think we need to take a step back. And we need actually to look at how do we gather that data? Why? Because as earlier stated, the production process is complex, but we start with the mixing process, which is kind of, a continuous process, and we go on, and move forward into a more discrete process. So, in the discrete production, it's much easier to actually to gather that data, because you get your vehicle inside or your body inside the final assembly. It has a vehicle identification number, and anything that happens during the production process can be logged against the vehicle identification number. So that's quite straightforward. Still represent a challenge for the automotive makers, don't get me wrong. But when we look at cell manufacturing, well, we don't have a vehicle identification number or a cell identification number, because that only comes at the end. So that means you have to, relate all this or relate back to all this data. So it's extremely important that you put in place, track and trace strategies to get really good quality data. And unless you do that, there's no way that you can apply data science to really get meaningful results out of your prediction, out of your algorithm, your data science algorithms.
Yeah, that's for sure. And I think you said that it is a bit easier with the discrete process, which definitely I agree with. I assume it's also possible with like continuous processes. But I think the main challenge here is that those processes are mixed and they are, let's say, present in the battery manufacturing.
Yeah.
For sure. So how is it solved then? How do you get the proper track and trace system in the lithium-ion battery industry?
Well, I think the main challenge is, as I said, when you look at, let's look at the process once again. We mix, we coat, we calender, we slit, we vacuum drive, we notch, then we wind or we stack, yeah? And then we go through a few other processes and we end up in end-of-line testing. And it's only at end-of-line testing that we know the capacity of the cell, right? So what we need to do is to make sure that the parameters that we record here at the end, so let's say, very simple example, the capacity that you are measuring, yeah? It's important that you can relate that back to maybe the tension that you had while unwinding your film somewhere in a stacker or in the winding machine, or what were the coating parameters that you had for this specific cell. So that is really important that you hand over the data properly from one section to the other one while you process your cell. And the challenge becomes even bigger. Why? Because you don't have one single equipment supplier for the whole cell manufacturing process. You will have one, to make it very simple, you will have one for the mixing process, you may have one for the cell assembly, and then you may have one, to really simplify it, for the end-of-line testing. Yeah? 3 different machine builders eventually, line equipment manufacturers, and they can probably implement these kind of track and trace strategies inside their production cell, inside their production line. But what you need is actually a uniform track and trace strategy that actually relates all the data back to the quality that you're measuring at the end. And I think this is a huge challenge. And this is where probably cell manufacturers will have to take a lot of responsibility of that process and drive it to really get the most out of their data.
Because for sure, when you are searching for machines, and it's always good to have like options, and you don't want to be always like finding one vendor that he will always provide the machines for you. You want to be more independent, but then you are always in front of this challenge of getting the right data from one machine to another. Yeah? So at the end, it's the responsibility of the battery manufacturer to create the proper track and trace system that can actually interconnect these different machines, yeah?
Or at least to specify it.
Right.
And to drive that the specification is implemented inside the different machines, yeah.
Right. So it seems like this is a huge challenge, but let's assume that we do it, yeah? And we have the proper track and trace system. How this improves the manufacturing? How is it? What kind of benefits this will create for the organization?
So let's assume that we just solved in 5 to 10 minutes this huge task, of track and trace. Well, what can you gain out of that? That's a good question. First, I think we need to look into machine learning itself, Because what we have now, if we have this track and trace strategy in place, the data that you record at the end, capacity, inner resistance, and all the other parameters that are actually measured with exact measurement equipment, It's very accurate data. And you can relate that back to your process parameters throughout the whole production process. Now, when we look at machine learning and how that works, what do you need for machine learning? Well, first, of course, you need to understand the problem. The next thing is you need to find and identify a certain algorithm, a certain machine learning algorithm that will actually help you to make the right predictions, whatever predictions you want to make. But these predictions mostly follow the targets that you've set yourself at the beginning of the project. But once you've done that, you have, let's say, a quite stupid algorithm at the beginning. Why? Because it's not trained. it needs to be trained. It does not have any kind of experience. So you need to feed it with training data. And what does training data look like? Training data is a set of inputs that you can feed that machine learning algorithm with. So the machine learning algorithm could be anything from a neural network to a convolutional one, or convolutional neural network, a recurrent one, or also more, let's say, earlier machine learning algorithms. But what they all have in common is you feed them with inputs, you run them through your machine learning algorithms, and then you look what it predicts and you compare the prediction to what it should actually be. So to what it should actually be is what you measure at the end of the line. So once you have that track and trace strategy in place, you actually create training data sets that you can use to train that sorts of algorithms on the fly. And you can do a lot. You cannot just predict your quality, but you could probably as well go and predict the process parameters that you require to produce the quality that you are aiming at, which is 100% cell.
So we are coming back again to a situation where putting the data in order not only allows you to improve the production process, that is the first step, but finally, because you have the right data, you can actually use data science to improve pretty much everything. I mean, you can start thinking about getting better machines. You can start thinking about creating better products. Yeah? And all of that is possible pretty much with the data that was already in the factory floor at the end. But maybe you were not able to use it properly. But once you put the data in order, you create a completely new world for yourself. Yeah, I think that's the case.
Yeah, absolutely. Yeah. And I think it can really support to unlock a huge potential. And that's the beauty of this process, because you have really all these process parameters that you can record throughout your process. And at the end, you got the label. I mean, logging this, if you crack that nut, the opportunities becomes actually quite tremendous. Yeah.
It seems this is a pattern that is visible in many different types of manufacturing. So it seems we have production processes which are already quite efficient. So it's very hard to, for example, speed up the machine or something like that. So the only competitive advantage that you can actually get lays in the data. So it's very interesting. Maybe let's discuss a specific example. So do you have, from your experience, can you share some example how the implementation of data science methodology was helping the manufacturer?
Yes, we actually do have an example. So our colleagues in Nagoya actually provided us an example of what they did. And the target here was to actually predict the thickness of the coated material on a metal film. And obviously you can do this by measuring with a sensor, yeah? But you measure it on the spot. But here, the aim or the target was, let's take parameters that are available from the automation architecture and let's derive a rule to predict the thickness of the film. So they went in and they looked at 127 different parameters. Out of these 127 parameters, they identified 4 parameters, which were the pressure of the coating tool, the distance of the slot die coating tool from the film. They took the temperature. They identified the temperature in the oven, so the drying temperature, and finally the tension. And by looking at these 4 factors, they were actually able to create a rule, to create an algorithm that was able to predict the thickness of the coated material on the film. And I mean, why is that important? Why is it important to predict the thickness on the film? Well, it's very simple. The thickness of your coated material on the film will define the capacity of your battery. If there is too little, you can store too little amount of lithium ions inside the graphite coating, for example. If there is too much, well, you may have too much graphite on it and your cell will become too heavy, or your inner resistance will be affected by it. So it's extremely important to have the right amount of thickness in your battery cell or on your film to be able to manufacture a good lithium cell.
Okay, that is, I believe, clear. However, maybe I will try to understand it a little bit better. So you said the thickness of the materials. In this particular example, the thickness was the key to understand and to measure. And the organization understood that there are four main factors that are influencing this thickness. Yeah? So I immediately obviously see the benefit that instead of looking at 127 parameters,
and you can look at a lot more. Yeah, there are thousands of parameters.
Probably there are thousands of parameters, but it was clear that in this particular example, these four parameters had the biggest influence. So then they could focus on those four and trying to improve the four parameters to make the production more efficient. Mm-hmm. And the identification of those parameters was possible with some sort of a algorithm, or how was this done?
So the way you do this is you need to make a correlation analysis. That means, simply put, when you look at your 127 parameters and you look at the quality. So what you need to look at is when my quality changes, which of these factors actually changes meaningfully also. And while doing so, they could actually see that these four parameters were actually changing in a more or less predictable way. So in other words, they had a high correlation with the quality. So correlation analysis is probably one of the quite important parts of data science, because that's actually what tells you what to focus on. What is the data that is required actually to predict reliably the outcome that I want to achieve in this case. And you can go actually even further than that, because right now we are talking about, predicting the thickness of the coated material. But what do you gain if you just predict the thickness and you see it's not enough or it's too much? What do? Well, you can readjust your parameters, of course, manually. But what you know is that your film that you're producing right now, quite expensive film, by the way, it's crap. And you may only scrap it, or you may produce very bad cells. And actually, that's exactly what you want to avoid. So you want to be in control of that. So what you can also do with this sort of machine learning algorithm, and I don't know if what was done in this case further on, but you can actually start to predict your process parameters that will then create the right thickness. So that will need, of course, a whole new project where you start again with a new correlation analysis, because now you need to correlate what parameters influences, the speed, the pressure, etc. And then you start actually to look at how you can predict the right process parameters. So actually your equipment starts to behave and be controlled with the right parameters to produce the best quality. Mm-hmm. And in this case, the right thickness.
Then again, it sounds like maybe changing the parameters in the fly is quite complex project to start with, but definitely if you have the reduced amount of parameters that you look at, then probably it's easier to implement. And then you are, as you said, so instead of wasting the material, you can actually improve the process as you go. And very interesting concept. Is this being implemented already in the factories? I mean, they are able to change the production?
We're not allowed to say where it's implemented. I mean, as a matter of confidentiality, of course, and we can also not disclose what kind of algorithms were applied, because this is actually something which is key as well to such a project. Because the one thing is to identify the data, which is one part of the job, but the other one is to identify what is the algorithm that I need to design to actually make correct predictions, and that is also a whole scientific field of itself as well.
Of course, and at the end, this is the source of the competitive advantage that we are discussing today. That's for sure, I agree. But definitely, each process is different and so on. So I'm sure that this kind of research can be done on each production site, and checking the parameters, understanding what can be done, creating the learning models. So of course each situation is unique. There are no answers for everything.
No, there is no one-fit-all solution in this case.
Yeah, perfect. So that is clear to me as of now. So let's leave the data science on a side for the time being, because you mentioned about the tension in the production process. So when I imagine the production process in the battery manufacturing, it seems like this keeping the right tension it seems like a challenge in itself. So let's say that you have a very good data science project implemented in your factory. You understand that the tension is the problem, but I think the tension in itself is a challenge, right? To get the right tension to the process.
Absolutely. And I mean, there is a reason why it was one of the 4 parameters to predict the thickness, yeah?
For sure.
Well, tension is challenging, yeah? And why is it challenging? Now, let's take a simple example. Let's take a rubber band that we actually expand, yeah? And let's just imagine what happens with it. Well, it actually gets thinner, right? But eventually, when you release it, it will get back into its own shape, yeah? If you stretch it too much, then it might have some plastic deformations inside. That means it does not come back completely into its original form. And if you stretch it even further, what happens then? Well, it breaks, yeah? And it's the same here, because when we look at the films that the cell manufacturers are working with, we are talking about films between 10 and 20 microns thick, yeah, for the copper film. And some cell manufacturers are probably even trying to go beyond that to reduce weight, to reduce the amount of copper used in the battery. So we are talking here about extremely fragile films, extremely thin films. But actually, they do behave or have the same properties as a rubber band, just slightly different. But a copper film can be elongated. And you can have elastic deformation and you can have plastic deformation inside it. And of course, if you apply too much tension, then it can break. And the point is that uniformity is one of the key factors to a good cell. So as we saw before, as I said before, the thickness of your coated material is extremely important in the battery. It has to be the same, yeah? That's the uniformity you need to achieve. Now, what happens if you elongate your film slightly because of tension fluctuations, yeah? So if you don't manage your tension properly in the whole process, we're talking about lines that are 50, 70 meters long, yeah? We're talking about stackers where they are being unwinded and then stacked, or winders where they are being wound to cylindrical cells. There is a lot of winding going on, so there's a lot of tension control to be done. What happens now if I elongate that copper film? Well, one thing can break. If it breaks, I see immediately I have a problem and I can take countermeasures.
But at least you know that you have the problem.
At least you know it. You're not happy about it, but you know it at least. But there are 2 other situations, I think, that are much more trickier. That is, for example, for the plastic deformation. That means I elongate the film and it remains in its shape. That can mean actually that the coated material can lose its adhesion to the film because you stretch the film, and what's happened to the coating? Will it also stretch the same way? Maybe not. So it will start not to adhere so well to the film anymore. What does that mean? It simply means the electrons in your battery will not be able to get as easy to the current collector. And in other words, that means that the current is not going to be as high as you want. So your battery will not have the properties that you want. Adhesion is one of the key factors as well in cell manufacturing. The other aspect is what happens if you have an elastic deformation. Now, if you have an elastic deformation, actually it was the other way around. The elastic deformation is the one who loses the adhesion. It's the plastic deformation that actually creates a cavity. So when you stretch the film, you create a cavity in your film. So, excuse me for that faux pas, it's the other way around. Plastic deformation is actually the one who is creating this cavity because it does not get into its its shape anymore.
And you're showing how complex the manufacturing in this industry is, right? So even if you have a very good methodology of solving, for example, thickness problems, you are still left with the actual mechanical surroundings, where you have a very thin foil that can easily break, and it will influence the quality of the final product. So this sounds like a huge challenge. And how then do you solve this? I mean, we are talking about the challenge with the tension. How do you assure that the tension applied to the material is the right one? What are the, what is the technology that actually executes the tension control?
So to manage your tension properly in such an environment, we have these long lines. So you need to manage the tension in sections. Because you can imagine that if you have a film that is just hanging over 50 meters, well, the tension will not be proper in that film. Yeah, it will hang. So what you're creating are sections where you actually manage in each section the tension. But you have to do that by using servo motion. And you will have an awful lot of access. So you will have an awful lot of access, for example, in a stacking machine. A stacking machine will have, way over 100 axes. And these axes need to be exactly synchronized to actually manage the tension inside the film. And to manage 100 axes, that is not trivial, because you need to do it high dynamically. And that is actually a field that we've been coming from. So probably all the batteries going into electrical vehicles today are coming from Asia. Yeah, and we have been quite successful in this market, working both with equipment manufacturers, but also with the end users to develop our products further. And over the last decades, this experience has enabled us to shape a product, an automation solution that is actually able to manage this and control this tension pretty accurately. But it's not only motion we're talking about. Sometimes you require different solutions to control the tension. So you also have setups or architectures where you're working with powder clutches, powder brakes, and tension controllers. So depending on actually the kind of tension control that you are aiming at, you will require different solutions. And these solutions have been developed by Mitsubishi Electric over the last decades, and quite a few decades, to be honest. And this is quite challenging to achieve.
I can imagine, but the process that you are describing, I think this is not only implemented in the battery manufacturing. I think this kind of applications where you have the material running on a couple of, hundreds of servo systems, this is something that is used also in packaging and so on. So I think the whole technology is available, but I assume it's easier to pack, let's say, food in the packages than to manufacture the foil, right?
Well, when you handle a packaging film, I will not say that it's not demanding. Yeah. So to all the packages out there, I'm not devaluating what you're doing. I think they have extremely nice and thought through machines. Yeah. But the plastic film that you unwind, for the packaging industry, it forgives a lot more than a battery film. Because the battery film does really not want to be stretched. Yeah, it does not want any stress. But if you stretch your packaging film a little, as long as it doesn't break, and as long as it's not a plastic deformation, it gets back into its shape, everything is fine. Yeah, that's something that you don't want happening in your battery. So I would say that this kind of roll-to-roll application is a lot more demanding, and that's where we're coming from. That's what we've been developing over the last decades, and it's probably also one of the keys to our success in Asia.
Okay, that is clear. And
one thing maybe.
Go ahead.
Yeah, one thing that I would also like to mention is that we actually have also developed a so-called roll-to-roll guide. Yeah, so it's actually a nice selection guide that does not just tell you what kind of roll-to-roll, or let's say what kind of controls architecture you need, depending on your roll-to-roll requirements. it also explains physically what's happening in the different actually roll-to-roll applications and what kind of parameters you need to consider. This is actually almost an academic document, to be honest. And that is something that we have also developed over the years, because, as I said, it's not always that trivial to understand what is the solution that I need. And that is why we have actually developed that as well, to support our machine builders to select the right tension control configuration that they require.
Okay. We are almost at the end of the conversation, so we have 5 more minutes to go. And later on, we will also do some Q&A session. So if you have some more questions, please publish them in the chat. I will ask Klaus a couple of those
I'll try
by
to
the end
answer
of
them.
the conversation. But let's try to summarize this. So we discussed the industry, and what I learned today is that it's a challenging place to do the manufacturing. So what are the sources of the competitive advantage at the end? What would you advise to the customers in this industry?
Well, advise might be a big word, because I think they know what they are doing. Yeah, I mean, it would be pretty displaced or misplaced to go that far. But in my opinion, I think being able to manage the quality the best way, yeah, can give you a huge competitive advantage. And the reason is simply, it can actually help you to reduce your operational expenses, because the less waste you produce, the more raw materials are transformed into a sellable product. So that's the one thing. That means your line is producing more revenue, yeah? And it's the same line with the same raw materials. It's just the process that defines the revenue in this case. So that is absolutely, in my opinion, a key to success. And that will become a key to success beyond, let's say, the path of the power generation sector becoming, let's say, 100% renewable, generating almost no CO2. But it's key that you really transform your raw materials, because energy is just one part. You have a lot of awful expensive materials. I mean, when we look at NMC chemistry batteries today, nickel, mangan, cobalt batteries, the price of lithium, the price of copper, the price of the different of the electrolytes, all these are quite expensive materials. You don't want to waste them, yeah? So even if you're not using that much energy, you want actually to have the best manufacturers of the highest quality, so you can maximize the revenue of your line. That's the one thing, the one part. The other part is, well, when you look at some of the initiatives in the European market right now, for example, the battery passport, where there's the idea that why not define and track and communicate to the buyer of the battery how much carbon dioxide, how much CO2 was emitted during the production of the battery. So while we still don't have renewable energies, yeah, while we still don't have 100% renewable energies and a very low CO2 footprint in the power sector, well, it's still important to, on the one side, of course, choose the location for your factory that has the lowest footprint. That's the one strategy. But the other strategy as well is to waste as little electrical energy as possible to actually make a battery that is as CO2 neutral as possible, to get as low as you can towards CO2 neutrality. Mm-hmm. So I think that's definitely also something that can help a cell manufacturer to manufacture his cell, to market his cell at maybe a higher price, and to make it more advantageous and more interesting for a buyer. So a potential buyer of a car may look into the CO2 that was emitted as well for that battery. And maybe it will not be allowed to sell batteries that are emitting too much CO2 in the future. I don't know where we're going, but
this is not the first time when I hear this. So in the past, maybe like 5 years ago or so, obviously the quality of the production was very important, and obviously you wanted to reduce the energy consumption in your production process. It was clear that you need to do it. But what I am hearing from you and also from people from other industries is that finally the consumer choices are also a factor to consider in this regard, right? So consumers become more interested in, getting sustainable products, and they are actually influencing the manufacturing. And that is very, very interesting.
Yeah, absolutely.
Very good. So thank you for this, Klaus. We are exactly on time. So normally I would make some small summary, but I think we can skip that because you summarized the point very well.
Sorry for that.
Thank you very much. And I think it was very interesting conversation, but we are not done yet. So for sure, I would like to spend maybe another 20 minutes to discuss some questions from the audience. And I see the first question, which is something that we could probably spend 20 minutes on.
Okay.
But if you could try to make it a bit shorter, because I also want to ask others. But someone is asking, what are the greatest challenges in the battery production and how to solve them? And I think how to solve them is...
I think my daughter is calling. I have to go. No, that is... what are the biggest challenges in the cell manufacturing process?
Well, one of them for sure is the quality and all the factors that influence.
I mean, we've been discussing this for the last 40 minutes. So, what the challenge is on the cell manufacturing side? I think, of course, one important aspect, and I think that we cannot emphasize enough on, because it will benefit not just throughout the cell manufacturing process, it will benefit throughout the whole value chain and of course other industries, is really that we get the power generation sector, of course, getting a lot more sustainable and focusing a lot more on renewable energies and trying to get that CO2 bill a lot further down.
But this is an unusual situation because the challenge for the battery manufacturing is actually the energy production that we cannot really influence. So we need strategies, like countries or European Union needs strategies to reduce the CO2 footprint.
Well, absolutely. I mean, there's still a long way to go. And when you look as well at the different emissions throughout the countries, I mean, I think I saw on Statista that in Sweden in 2021, per kilowatt hour produced, it was 10 grams of CO2, whereas actually in Poland, it was 736 grams CO2 per kilowatt hour, which is quite a tremendous factor of 73. Yeah, and even in Germany, 349 grams CO2 per kilowatt hour. So you see, there's depending on the countries, a lot of work to be done. But to come back to the question, what are the challenges? I think one of the main challenges that I see, at least when we're talking about cell manufacturing, it's probably to get that track and trace strategy in place. You can probably focus on specific processes, smaller processes, to make it easier to tackle, to gain, let's say, to get the first successes ongoing, because it's important that when you spend a lot of time trying to achieve something, that in terms of fighting the frustration, you need some successes as well, and you need to justify that towards your management. But it is really, I think, getting this track and trace strategy properly in place, because it's not that easy really to say on meter 221, I had these coating parameters and they correspond to that cell. That's something that is probably extremely challenging to achieve. But I think the data science part, when you look at the multitude of different algorithms, and I mean, even if you choose a convolutional neural network, that doesn't mean that the job is done. You still need to shape it, and that can become bloody complicated. And that's something that you need to manage as well. So from that perspective, these are some of the challenges that I definitely see. But I think it would be the fairest to actually ask a cell manufacturer how or what are the biggest challenges that they see.
Yeah, and I think one more advice we can give on that is actually we discussed this on our video cast last month, that whatever you do, it's better to start small. Yeah. So you find, as you said, like a specific process, and then you identify what you could be able to improve in it, and start small, because I think this always pays out. Yeah? Perfect. I will ask one more question, which is also a bit more holistic, and probably we could have another video cast to discuss this sometime in the future. But maybe briefly you can also say something about the recycling process, because obviously there is a lot of new batteries appearing, right? And the production capacity in Europe even is getting much bigger. But I think it's a valid question. So how do you handle the recycling? And is there a technology for recycling of the batteries?
I think there are many projects going on with regards to recycling. And what is also nice to see in this whole endeavor of electromobility is that for once, we don't start with the technology and try to introduce the technology to the market before identifying the whole impact. So there are already today as well a lot of projects going on with recycling, because we've realized, well, we need to look at second life of batteries. We need to look at how to recycle the batteries when we can't use them anymore. So that is, I think, a very positive signal that we see here. There are a lot of projects, as I said, and the batterynews.de is also a good website to go to, because they have all the projects listed there that they know of, and it's quite a lot. And from what I've seen is, well, we have, when it comes down to recycling, a few challenges, because every EV manufacturer will have his own shape of modules. Yeah. So, which highly depends on the way he's designed the car. And when you get that into a recycling facility, well, it's like getting almost a black box. I mean, you need to open it. Of course, you discharge it first, but then you need to open it. And once you've opened it without any harm, then you need to get the cells out. I mean, if you have one battery module, it's easy. But if you got thousands of battery modules, then you need to automate the process. And that's where the challenge starts, just to dismantle these modules. The second challenge that you will then be faced with is, what do you do with the cells? Yeah. So today we're able to produce the so-called black powder with I think it's with different separation methodologies within the recycling area. But once we have this black powder that is full of nickel, mangan, cobalt, lithium, then you want to actually separate that as well. And there are processes on the go to do so. But I think what is also needed, of course, is in Europe a huge amount of recycling facilities for that, because even though I think the EV sector is going to contribute by 2030 to 80% of the battery demand, there is still 20%. And I'm not so convinced that it's only 20%, because we haven't even looked at, stationary energy storage, which is probably going to create a huge demand as well, but different chemistries probably.
But from my experience, I can say that for sure all these recycling facilities are also highly automated. So these venues are already quite modern and advanced. And that tells me that we are not only advancing in the battery production, but the recycling part is also handled quite well.
Yeah, absolutely. And actually one company who is really very strongly into that as well. I mean, we know them for cell manufacturing. They've been very prominent for cell manufacturing. It's the colleagues up in the north of Sweden, Northvolt. They also have a facility called Revolt that you can read about, where they're actually focusing.
It's a clever naming. Huh?
Exactly. It is clever marketing. And the guys are clever up there, I'm sure. So, and what you see is they're not just thinking about manufacturing cells, they're also thinking about actually how to recycle them. So they are looking at the whole, at a wider life cycle. It's not just about manufacturing the cells, and off we go.
Okay, but as I said, I strongly believe that potentially we could have another conversation about only that, right?
Yeah.
Okay.
And I need to do a lot of homeworks actually to show up to this one.
There is a more detailed question, which is related to the discussion about controlling the tension. So someone is asking why tension controller is better than the servo system. And I'm not sure if this is always correct, right?
No, you cannot say that the one is better than the other one. It completely depends actually on the application itself. So the main difference between a tension controller and tension control via servo motion is that with servo motion, you can do tension control over speed and torque. Whereas with the tension controller, you can only measure the torque. So or you can only adjust it over torque. You don't consider the speed into that. The other advantage, of course, of let's say of the tension controller itself, when combined with powder clutches and powder brakes, is that it's much smoother. But it's maybe not for the most highly dynamic processes, if that's an aspect that you require. So it really depends on the size of your line. It depends on it really depends on the application itself. It's I think if you take a look at that roll-to-roll guideline that we have put in place, or that the Nagoya colleagues have really nicely done, you will see when the one fits and when the other one fits. And they all have their advantages and disadvantages, obviously, because if not, there wouldn't be two separate technologies.
Okay. Could you repeat the name of the website that you mentioned? Because some colleagues want to know about
So there is one about all the battery projects, about all the recycling projects, material projects. It's called battery, in English, -news.de. And there you will find a lot of information. And to actually, for the statistics around the different CO2 emissions, I went to statista.de. But I think that's something we can post as well. It's not a secret. It's publicly available data. And I think the audience actually deserves to see the source.
Absolutely.
And I think it's important for the credibility of the statements that have been made today.
Perfect. There is one question in Italian. Sorry, I cannot read Italian. So if possible, could you try to ask it in English? Otherwise, we will contact you separately and we will try to help out. But there is another question which is, I think, quite difficult. So we have so many factories that are producing, traditional cars, And since the industry is going into the direction of electrical cars, so what will happen with all of those manufacturing places in the whole Europe related to traditional car manufacturing?
Oh, that's also good. It's actually a very interesting question, I think. And probably the automotive manufacturers are best placed to answer the question. But I think, first of all, cars to be economically viable for us in Europe, but throughout the world, you need to have a kind of local production, which is also one of the reasons why we produce the cells locally. There is no reason to ship them around the world. The same with the cars, And that's also probably why we had, I think that was in 2017, the peak year, something like 15, almost 16 million cars produced yearly, which is quite a lot. And I think that it will remain. So what will happen with the factories for conventional cars? They will probably be refurbished to manufacture electrical cars. I mean, look at BMW. They are actually producing electrical cars I think it is in Munich. And when I was working there, at least, there was no electrical cars being produced, only combustion, only conventional cars. So I think there is, of course, going to be a lot of projects to refurbish the existing lines to fit the manufacturing of electrical vehicles. There's a big job to be done, a lot of investments to be done here, but I think it will happen.
No, I completely agree. I mean, today we discussed the competitive advantage of the, EV industry, among others. And I think one of the big competitive advantages of the traditional car manufacturers is the know-how. So they know how to produce. They know how to do it efficiently. So now it's only the matter of, let's say, changing the product. I know it sounds simple. Of course, it's not simple. But at the end, eventually, this is what it means. The Italian question was translated to English, so I can ask it now. And actually, it's a very good question. So today, we didn't discuss the other challenges that we might face. And the question is about, there is a really growing need for the batteries, right? Mm-hmm. There is more electrical cars produced, and then obviously the need for batteries is really high. But these days we have a lot of issues with the raw materials, right? Mm-hmm. And there are disrupted supply chains all around. And how do you, let's say, combine those two? So you have the huge demand, and you have problems with the raw materials. How do you find a way to make it happen? It's a tough question.
If I had an answer to that question, I think, my phone wouldn't stop ringing. I think absolutely this is a huge challenge. It is. And even once the supply chain is not as disrupted anymore, the question is still, how do we make sure actually that we keep all these raw materials as well in Europe? Because once we have, imported all these, we want to reuse them, to recycle them, and to make new batteries out of those. Yeah. So I think recycling is an important part, but it's not going to solve the problem in the short term. Definitely not. So this is rather a long-term, I think, strategy, but a very important one, because if we don't do these homeworks today, we will face the consequences tomorrow. How to deal with these, with the disruption of the supply chain today? I think if you want to order a car today, you are going to wait quite a substantial amount of time, over a year, before you get it. Mm-hmm. That's the new normal, apparently. Another new normal. But I don't really have an answer to that, because I think it's such a complex topic that comes down to logistics to get all these products to us. I mean, I know that there are projects ongoing, for example, to extract lithium in Europe as well, but I mean, they're not mature yet. I think there is no mature solution right now. I think we have to manage the situation as it is.
However, as far as I know, there are some new investments, as you said. So there are countries who have some sources of those materials. They have resources, and there are being new investments done. But of course, it will take time. That's for sure. That's why, as you said, it is very important to recycle the batteries, but also improving the quality. So instead of wasting the material, you can actually use it properly and efficiently.
Absolutely.
Okay, 3 more minutes to go, and I think we can ask maybe one more question, which I have seen. It's again very detailed, but how did you identify those 4 parameters in the case study example? So the ones that influence the thickness of the material. Yeah, so I think you mentioned this.
That's where I mentioned the correlation analysis, actually. Right. That, meaning that we are actually, we took the 127 parameters and saw which one of the parameters are behaving in a predictable way as we change the quality parameter, the thickness in this case. Mm-hmm. And then we identified these 4 parameters out of that correlation analysis.
However, each situation will be unique. I mean, that depends on the machine used and the materials and so on. So that's for sure. Yeah. Okay, last one, because it just showed up. So it seems there is a lot of developments around the Chinese brands in the market. And do you believe that the Chinese car brands or battery brands will dominate the market, or will Europe, be competitive in this industry?
I think we have a lot of know-how when it comes down to car manufacturing. I mean, electrical vehicles it's not just about electrifying the vehicle. I mean, we know that it takes a lot more to create a good car, yeah. And I think there are many European manufacturers that have demonstrated that they've been able to manufacture very good cars that really respond to the European needs. So I don't think that they are going to dominate it. Probably they are ahead of us right now. I mean, there's no doubt. We can't deny that. And if the European automotive sector wants to catch up on that, I mean, they need to really accelerate the activities they're doing. And when you see at all the different battery projects around in Europe, of course, there are a lot of Asian cell manufacturers, specifically in the eastern part, but also even in Germany. But there are also a lot of very promising projects, European-based or European headquartered companies that are manufacturing cell, and I'm sure that they will be able to overcome the challenges. There are still probably specifically in the way you exploit the data that your line is producing, I think there is a huge opportunity here to actually gain competitive advantage and being able to produce them, accordingly here in Europe. Why should we not be able to do that? And why should we not be able to acquire the necessary knowledge? I think it is possible.
Yeah, I think we are coming back to the point that we discussed in the beginning of the podcast, where we said that the industry is also affected by the how clean is the energy, right, in Europe. So I think if we advance in getting, green energy in Europe, then Europe automatically will start being more competitive, right? Because we will be, if we use renewables, yeah, I think that will be one important factor. And I think we are, with all of the current trends, it seems like Europe is leading the way when it comes to getting the renewable energy. Perfect. I think we will finish here. Thank you very much for this hour, Klaus. And I'm sure I will invite you again. Thank you, everyone, and see you soon. Bye-bye.
Thank you.